Thank you for the invitation. So my name is Henri Haimi, and I work as a process design engineer in engineering company Finnish Consulting Group. So I'm about to tell you about utilizing data in biological wastewater treatment. There is the outline of. First I will tell you about background for these issues, then something about the instrumentation and data collected in wastewater treatment plants, then process monitoring, control, modeling, and something about what will be likely to happen in the future with these issues. So there are some driving forces for more advanced automation solutions in wastewater treatment plants. First of all, the treatment requirements are tightening all the time, and this leads to more complicated and complex unit processes, and also not only unit processes but a sequence of several unit processes. Of course, we want to optimize or minimize the operational costs. This is one issue behind this development of different kind of automation solutions. We want to use the plant capacity efficiently in different kind of situations. And one of the fundamental things is that a wastewater treatment process or plant is a dynamic system. The influent flow rate and different pollutant concentrations are changing all the time. There are different kind of situations, dry seasons, heavy rainfalls, and in Finland also snow melting time is quite difficult. And what makes possible to develop and use these advanced automation solutions? First of all, we need online instrumentation, which has developed a lot during the last decades. Of course, actuators are important. We need to, for instance, we have pumps which can be used in different speeds. Valves are getting better, and so on. Fundamental thing is progress in information technology, telecommunication. We need to transform the data. Process knowledge is something which is required also in developing automation solutions. And of course, know-how and education of the people who work in the plants, and also of the people who design these plants is also very important thing here, which makes it all possible. This is just an example about online process measurement in wastewater treatment plant. This is Viikinmäki wastewater treatment plant in Helsinki. It's quite heavily there are plenty of process measurements, especially in this activated sludge process. All the measurements are not shown here. And of course, there are flow measurements, level measurements, pressure measurements, and so on. There are thousands of digital signals measured all the time. And this data is then gathered together. Some usual online measurements in wastewater treatment plants are shown here. These are used for different purposes, and some for instance, conductivity is used for monitoring changes in the influent wastewater. Then, of course, dissolved oxygen concentrations used in aeration process and control of it. We have different nutrient concentration analyzers and also sensors which are used for control purposes. Sludge blanket level is something that used to be quite challenging to measure, but the instruments are better nowadays, and this is used in especially in a secondary settling tank. if there's a digestion process connected to wastewater treatment plant for sludge treatment, then we have special measurements also in that site. So we have lots of operational data available. We have these online measurements and also laboratory measurements, field measurements, and so on. What is especially important here is to keep these instruments clean and calibrate them. The maintenance of the instruments is the basics for all the other things which can be done based on this process data. So I think it's important to have a maintenance plan for these sensors and analyzers, as well as maintenance contracts with the instrument suppliers. We can cross-check the instrument data with laboratory measurements and also field measurements, just to validate the data and the measurements so that they are working correctly and precisely. So we can, what is useful is to collect all this data, measured online measurements, laboratory data, and field measurements, some calculated variables like sludge age, different reductions, and so on. This can be collected in digital process logbooks, where everything is connected and can be found for future applications or analysis of the process afterwards, different reporting tasks, and so on. There are some sophisticated methods for data validation also, and screening and filtering the outliers and other data samples which are not correct. So we have process data, and this is a basis for many things: process monitoring, analysis of the process, process control, and also process modeling. Process monitoring can be done in many places nowadays. Traditionally in control room, then we have nowadays remote applications. Usually we have upper and lower limits for different process variables. We can check time series of different variables, scatter plots, two variables against each other, and so on. We can have calculated indexes which combine, for instance, treatment results and energy use or chemical use or costs. Then there are sophisticated algorithms which can give some advice for monitoring the process with a huge number of measurements, and this can advise you about different process states and where the process is going to which direction. And the aim is to find and isolate sources of deviation from this normal operational state. There are different levels of process control, especially in wastewater treatment in these cases. First level is just have a laboratory measurements, manual sampling, and then based on these laboratory measurements we can do some manual control actions in a plant. Of course, time delay is long. Then second level we have online nutrient measurements. Based on this online data we can do some manual control actions. Or third level is we have this online measurements and control actions are automated. And in the future maybe we can have more advanced systems there's automatic analysis of raw data or screening. We have online control and control tuning and some automatic reporting tools also. Basic control system is a feedback control. We have process, then there are some disturbances which usually are changes in influent, flow rate or concentrations. Then we measure some variable, compare it to set point, then there's a difference and the controller gives some control signal to actuator like a pump or valve, and in this way process is controlled. Feed-forward control tries to do the control action before the actual change will happen in a, for instance, activated sludge process. It's often also connected with feedback control loop. There are advanced control systems, model predictive control, rule-based control, such as fuzzy control, which are not so usual, but they are getting more applied. We have tested those in Finland also. Process data can also be used for modeling purposes. We use historical data to build a process model. Then we can use some not online data but stored historical data for simulating dynamic process behavior. There are many commercial modeling software available, and there are different purposes for using these models and software. We can optimize process operation, not in real life, but in the simulations, and try to find some good operation strategies in a plant. For instance, if there's a high flow rate, we can try to find some optimal way to handle this. We can study behavior of an activated sludge system, which is quite complicated. There's biology, chemistry, physics, all the things involved. Modeling can also be used for training employees, or for instance, it's used in universities for training students. We can test different control strategies or algorithms offline with simulations and compare it to these strategies which are used in real life. Of course, in engineering companies, modeling is also used for process design or just to help some clients with their difficulties to, for instance, to reach the regulations set for them. This is just a example about what this modeling software can be like. There are there is a process model, and then which is built based on historical process data, and of course all the information about the plant design, and then we can test different, for instance, different control actions. Then something about what can be used in the future with this all this process data which is collected. First, we have sensors, we have telecommunication to transform the data. It's all stored in the database, and from database you can use this historical data for different purposes. You can analyze the data or some parts of the data, and then get more information about the process behavior. Then also you can go a bit further and make some new products based on this process data and some mathematical algorithms. And there's an example about this. It's called software sensors. So these are software used done by just coding, and there we combine measurements from several variables with a predictive model, and output what we get is like a virtual instrument which in a traditional situation provides you estimation of some variable which is usually not easy to measure, and the inputs we used are easy to measure. So these data-derived soft sensors, they are built on around process models which are derived from this historical data. There are many steps, I don't go there now, but anyway, this historical data where the information about process operation and behavior is encoded is used to extract more practical information for plant operators. And this kind of software sensors are more popular, for instance, in process industry, but they are getting more popular also in wastewater treatment. I've been included in a study earlier when I was at the university, and we did a review study about use of soft sensors in wastewater treatment. Most of these case studies focused on online prediction of some variables. There were some applications for process monitoring, just trying to give a process operator information about where the process is moving, and also sensor monitoring. So if the sensor is not working correctly, then we can isolate such faults. One example, and this is about Viikinmäki wastewater treatment plant in Helsinki, post-filtration process where denitrification takes place. There's methanol dosed in this process for external carbon source, and methanol dose is controlled by nitrate measurements in all of these different filter cells. So we designed soft sensors which estimate nitrate concentrations in these filters. And these estimates were quite successful. Prediction error was smaller than error of hardware instruments. And in this kind of case, we could use these software sensor estimates for controlling process, in this case controlling methanol dosage. For instance, when there are situations that the instrument signal is not available because of maintenance or some error. Another thing which is now getting more popular is plant-wide control. Usually we control one unit process, for instance, activated sludge process. It's kind of isolated from rest of these process units, but these process units are connected to each other in real life, and operation and control of one process unit affect some other process units. So we could have some kind of goal for overall goal for control and operation of the whole plant, and then this top level gives some control set points for other control loops for different unit processes. So aim is to have a maximum use of the whole plant and coordination of all the control actions. This is also an example from Viikinmäki wastewater treatment plant. There's a control of sewer network or influent tunnel is connected to control of wastewater treatment plant, and there is a weather data used for this application, and when the idea is that when there's a rainfall coming, we can use the capacity volume of this influent tunnel to store as much as rainfall water as possible. So aim is to avoid the situations that we need to bypass, for instance, activated such process because of the high flow rate. And the nice thing here is that we have this process data, we have data from this sewer network, but we have also some other data sources which can be used, in this case, weather forecasts or measurements. So my conclusions, fundamental thing is regular maintenance of the instrumentation. Too many cases I have faced that there are instruments which are not working, and we don't get the information from the process. We can, what is useful is to collect all the data in this digital diary or logbook, so that all the data is there for further purposes. Monitoring tools can be used for detecting and isolating disturbances or different process states, also instrument states. We have development in instrumentation, and this favors advanced automation control solutions. Process modeling can be used for different purposes, for instance, testing different operational strategies. And then what is a bit new thing is that we can code some new software which extracts new information from multivariate process dataset consisting of maybe 10 or 15 different process variables. And then integrated control of many process units can be used for optimizing the operation of the whole plant. Okay, thank you. This was my presentation here. So I think we can move on.
Thank you, Henry. There is some questions that I sent to the chat box. If you could please shortly give your comments about these. The first one is about this forthcoming DigiLeap or utilizing of this data. What do you think? What kind of services or training would be needed in wastewater treatment plants in future to make this data utilization more implemented?
Yeah, first thing is that we have more and more data all the time. Of course, it's a good thing. We have more information about process, but on the other hand, it makes it also a bit complicated if we have hundreds of measurements which we should be following. So I think that what would be needed is some kind of, for instance, software or things which collects the information and extracts the information from these huge amounts of data. This is one thing that I consider something that will happen in the future. There are different, for instance, neural networks that can be used for these purposes, or then multivariate statistical models. Then, of course, we have, like with mobile phones, we have different applications. I think that this kind of applications probably will be more popular in wastewater treatment plants too. Not using mobile phones maybe, but some kind of mobile systems and remote monitoring, of course.
Okay, thank you. What about, do you have any tips for the wastewater treatment plants who are planning to use more data and utilize the automation in their wastewater treatment plants? How to get started and what should be taken in consideration?
Well, the first thing is to collect the data in a database or this digital logbook, so that everything is there available, and to make sure that these instruments are working. And I think that the automated control is when the instruments are working properly, automated control is something that we should aim for instead of manual control. For instance, when we have this activated such process that aims for total nitrogen removal, we often have different zones in a basin. Some of them are aerated, some are not, and in many plants we or these operators they decide and change manually these zones from aerated to non-aerated state. But this all should and could be done automatically, with automatic for instance using some nitrogen online measurements, and it is done in many places, but I think it should be more applied. So,
thank you. It seems that there is one question more, that what software you are using for the process modeling?
What we have been using in Finnish consulting group is GPSX. It's a product of Hydromantis. There are BioWin is popular. Then there's a Sumo is something which is quite new software, but it's made by very talented people. So there are many options, but GPSX is what has been used in this company. And also
Sorry.
about this software, that in Finland there are nowadays, I think there are a couple of plants which have own modeling software, so they can test different things there without testing it in real life in process, but they can test it in these simulations. So these are getting more popular also in wastewater treatment plants.
We can start our second presentation of this webinar. Okay, thank you very much, Henri.